All right, hope everybody had a good weekend. Nice long weekend for you. Get that Friday off. On Thursday, we started working with our Z tables, looking at the Z tables. Once again, as we talked about, when you're talking about area, you're talking about probability. Area and probability are synonymous with each other. Your Z table, when you read your Z table, you have a bell-shaped curve. You have your zero value. That's right here in the middle. This is where your mean's at. This is where your mean's at for your set of data, because when you're talking about standardizing a set of data, when you standardize a set of data, that means you change all your data values to a z-score, and you take the average of all those data values. The average will come down to a z-value of 0 and an average of 0. Our standard deviation that we're going to get is a value of 1. When you're looking at a z-score, you will calculate or be given a z-score, whatever that z-score is. The table value will be the area between the z-score and this value of 0. So when you deal with your calculations, you're going to get an area between these two. Every time you do a z-value table or a z-value problem, you should be doing a bell-shaped curve. Every time, and you'll be doing bell-shaped curves throughout the rest of the semester here. We will continue to go back to bell-shaped curves and working through bell-shaped curves. Questions you have about any of the problems? We did a couple as an example on Thursday. Is there any that you still need me to go through? Solutions were provided for you. Hopefully you worked through. Maybe you didn't get through all of them, that's fine, but hopefully you worked through quite a few of them. Sometimes you'll be just looking at your table value. Sometimes you'll take your table value and subtract from 0.5. Sometimes you'll take your table value and add it to 0.5. Sometimes you'll have two table values that you'll add together. Sometimes you'll have table values that you will subtract together. Once again, what I expect of you and what's important for you is show me your table values. What are your table values? And then what operation are you doing? Are you adding from 0.5, subtracting at 0.5? Okay, maybe don't have to do anything at all. Are you adding or subtracting the values together? Show me the operation that you're doing. But also show me your table values. I don't expect anything else in regards to that, except for if you looked at solutions, you saw bell-shaped curves every time. I need that for my visual to be able to get through the problems. Anything? All right, now today we're going to start dealing with some application of them. The worksheet that you did, the Z values were given to you. The Z values were given to you. Now, what we will do is we will have a problem that you'll have to pull the values from the problem, calculate a Z value, and then do an application of your Z table. So it's that next level of type of problem. Once again, mathematically, we'll not ooh and ah you here. Once again, Z value or Z score, when I'm dealing with a Z score, is value minus mean divided by standard deviation. Value minus the mean divided by standard deviation is how we calculate a Z score. Whether it's a sample mean, whether it's a sample standard deviation, population mean, population standard deviation. Obviously, we would like to deal with the population, but sometimes that's not given to you. So we have to settle for our sample, and that's okay. Also, when we talk about probability of something occurring, we're talking about area. And your your Z table will give you areas, which will give you probabilities. The mean salary for a teacher for their first year is $28,200. If the distribution is approximately normal and standard deviation of $3,000, what percent of salaries are below $29,200? We are given the mean salary is $28,200. So we're given X bar or mu, $28,200. We're given a standard deviation of $3,000. And once again, this could be, it doesn't say population or sample. This could be mu. This could be sigma. We want to know what percent of salaries is below $29,000. What percent of salaries is below $29,000? So the first thing that we're going to have to calculate is what is the z-score for $29,200? What is the z-score for $29,200? How we calculate a z-score is value minus mean divided by standard deviation, where our value is $29,200. Our mean is $28,200. Our standard deviation is $3,000. So we have value $29,200 minus our mean $28,200 divided by our standard deviation $3,000. Now you're going to want to take this to 2 decimal places because our table is to 2 decimal places. Round to the 2nd decimal place. Jade, what's our z-value? 0.33. Okay, it's 0.33 repeating, rounds to 0.33. So we want what percent of scores or the probability that our z-value is less than 0.33. The percent of is also your probability of, which is also an area. So we're looking at our z-value of 0.33. Got our 0, we got a z of 0.33. We want to know the probability or the percent of scores that are below this 0.33. So we can go to our table. Find an area for 0.33. Once again, we will be using that table throughout this entire chapter. Our table value, Rachel, for 0.33 is what? 0.4988. What'd you say? For 0.33? Not 3.3. .1293. So we have 0.1293. So my area here is 0.1293. I want to calculate this entire area over here. So Ethan Farnsworth, what do we got to do? Okay, so this will be 0.5 minus the 0.1293. That will give me all this area over here. Far right, I want to know the value that's below. I want smaller than the 0.33. So what should we do with our area? What should we do with these two values? How much area is this? Add them. So we're going to have the 0.5 plus the 0.1293. So we have 62.93% of the salaries are going to be below the 28,200. What is the percent of salaries that are between 26,000 and 30,000? So what we need to calculate is a Z-score for $26,000 and a Z-score for $30,000. So calculate your two Z-scores. And we want to find the percent of scores, so we want to calculate the area between those two values. So you calculate two different Z-scores. Check those Z-scores with somebody around you. Do a bell-shaped curve. And then what will you have to do with your table values? Once again, take it to two decimal places. Should have one positive and one negative. Get your table values that you find your Z-scores. What do you have to do with your table values then? Once again, periodically check your answers with somebody around you. Sydney, what do you get for your two Z values? 26,000, you get what? And 30,000? Okay. So find your table values for those two. 0.73, no, what do you come up with 0.73 table value? And 0.6? 0.2672 and 0.2257. What are we going to have to do with these two values to find the total area, Jalen? What are we going to do with these two values? I want to find the entire area here. This area is 0.2627, this area is 0.2257. Add them together. So we have 0.2627 plus a 0.2257. And once again, this is what I need to see right here. This is what I need to do. When you add them together, what do you come up with? .4884. So we would have 48.84% of the salaries will be between those two salaries right there. Survey found that people keep their microwave on an average of 6.2 years, standard deviation 0.75 years. A person decides to buy a new microwave. What's the probability that they will own the oven? Less than 5 years, between 5 and 8. We're going to just do the last one here. We're going to deal with the more than 8 years. Okay, we're going to look at just more than 8 years. We have an average of 6.2 years. We have a standard deviation of 0.75. And we want to know what's the probability or the percent of that we are greater than 8 years. So let's calculate a z-score for 8. Calculate your z-score for 8. And we're looking at the probability that z value is going to be greater than 8, or greater than that z value for 8. Now, when you calculate your z-score, what I suggest you do take 6.2 minus 8, hit your enter button, and then divide that. It will pull your answer down. Divide that by 0.75. Or the other thing that you could do is you can quantify this right here. Because if you go 6.2 minus 8 divided by 0.75, what it'll do is it'll take 8 divided by 0.75 and then subtract that from 6.2. Okay, your calculator will follow orders of operations. So you can either quantify the top or take the top, hit enter, and then divide by 0.75. Your calculator will pull down the answer. Justin, what do you give for a z-score for 8? 2.4. So we have 2.40. All right. Find your Z value or your table value for 2.40. Okay, then what we have to do to be greater than that, so you're looking at the area on the outside over here. You're looking for that area here, because this would be your greater than. Okay, then Stutz, what's your table value? 0.4918 for 2.40. Then to calculate my area that's out here, what are we going to have to do to calculate the area that's out there, Jenna? Okay, so we have 0.5 minus the 0.4918. And what do you come up with? So we have a 0.82% of the microwaves that will last more than 8 years. And when you're talking about manufacturing, okay, they are in the mode of manufacturing that everything is very disposable anymore. Very disposable. So they have to have these ideas and these statistics to make sure they can stay up with their quantity of microwaves, because if people are getting rid of their microwaves on a fairly regular basis, they need to have microwaves in the stores so people can buy them. Not right now where there's nothing in the stores. But all these problems are very similar to what you did for today, except for now you are doing the calculations for the Z value. Okay, rather than the Z value being given to you, like I did for the worksheet for today, gave you the Z value, you had to calculate. Now you have to take that additional step and calculate the Z value. What we are assuming that our data is normally distributed. You have no skewness. Now, is it perfectly normally distributed? Probably not. There's not much data that's perfectly normally distributed. But if it's close enough, it's okay, because we can get data values and we can get statistical analysis of values using normal distribution, even though if it's not quite normally distributed. Because they always say it's close enough for government work. It's close enough. At least we have data values. How we can check data for skewness? Okay, and just one last thing before we go there. When we will only deal with in this class in statistics, stats 1, normally distributed data. When you get into stats 2, the next level of statistics, you deal with all the data that you have skewness to. And you'll be doing the exact same thing that we're doing now, but you'll be dealing with skewed data, and you'll be dealing with tables that will show skewness, and there'll be a Z table basically for skewed data rather than a normal distribution data. But how do we check for skewness? It's called what is called Pearson's index. And how we calculate Pearson's index is we take 3 times the mean minus the median, and we divide it by the standard deviation. The basis for Pearson's index is when you're talking about normally distributed data, the mean, median, and mode should be equal to each other. If it's perfectly normally distributed, the mean, median, mode will be equal to each other. Okay, if they're slightly off, we can still deal with it and say they're normally distributed, but if they are equal to each other, this value comes down to a value of 0. And there's different levels of relativity here. That's a relative idea. If your Pearson's index is greater than 1 or less than -1, you can conclude the data is significantly skewed. So if you're greater than 1 or less than -1, you're going to get skewness. In addition, you have to check for outliers. So if your Pearson's index is between 1 and -1, and you have no outliers sitting there, you should be good. Once again, how we calculate outliers, this goes back a couple chapters. How we determine if we had outliers, we took 1.5 times the interquartile range, added to your lower quartile, and subtract it from your lower quartile and add it to your upper quartile. Take your interquartile range, which is your upper quartile minus your lower quartile, multiply it by 1.5, add it to your upper, and subtract it from your lower. That was your test for outliers. If your Pearson index is between 1 and -1, you have no outliers, you can conclude that you have a normal distribution, approximately normally distributed. Once again, it's a relative concept. If you lie outside the range of 1 and -1, but no outliers, you can say it's somewhat skewed. If you lie outside 1, -1, outliers exist, you're going to get skewedness. given a set of data, we want to determine a Pearson's index and see if we have some skewness here. Well, what we need we have 3 times x bar minus the median divided by the standard deviation. So what we need to calculate is we need to calculate the x bar, our mean, our median, and our standard deviation, which takes us back into the first chapter. We have x minus x bar, and we have x minus x bar squared. $33, $48, $42, $78, $41, and $58. First thing we calculate is our x bar, so we can add them up. Add them up, divide by the total number of values. And we calculate our mean. Get the mean to be 50. So we have x minus x bar, and then x minus x bar squared. We have negative 17, negative 2, negative 8, 28, negative 9, and 8. And we can square each one of those values. And how we calculate our standard deviation, we take the sum of the x minus x bars squared divided by, we can call this a sample, divided by n minus 1. I'm sorry, this is your variance. My bad. should have 257.2 for your variance, and then your standard deviation is the square root of that. Sixteen point 16.0. It's round to the one more place value than your data values. You get 16. Then we calculate the median. So we have to list from least to greatest. Grace, and the median comes down to what? 45. I'm sorry, what? 45. 45. So the median is 45. So we have 3 times the X bar, which we calculated to be 50, minus 45, divided by our standard deviation of 16. So we have 3 times 5, which is 15 divided by 16. Ella, what did you come up with? So we're close to the value of 1. Okay, so we're very close to the value 1, but we're less than the value 1 still. So we hit that parameter, but we can take a look at your upper or your interquartile range and your outliers. Your median's at 45. So we have 58 and 41 as your upper and lower quartile. So your interquartile range is 58 minus 41, which is 17. Multiply that by 1.5. $25.5. So we can add that to the upper quartile. We can subtract it from the lower quartile. So we get 86.5, and this gives us 15.5. My highest value is 78. My lowest value is 33, so I have no outliers. We have no outliers. I'm in between 1 and -1 with my Pearson index, so I can conclude that I'm going to be normally distributed, approximately normally distributed. It may not be perfect, but I'm not outside of that range of 1, and I have no outliers. So I can conclude that I have a normal distribution here, approximately. Once again, it will not be exact, won't be exact because my median and my mean, I have a 50 as a mean and a median of 45. I'm not going to be exact. If I'm not equal with those two values, then I don't have a normal distribution, or perfectly normally distributed set of data. But it's a way of gauging, do you have a normal distribution or not a normal distribution? A lot of work for one little value. Okay, your homework tonight is basically looking at applications of the z-table. The one, once again, additional step that you'll have to deal with now is you'll have to read a problem and calculate your z-value and interpret what you have to do with the z-value from a problem. Very similar to what we just did here. Questions you have? Okie dokie, the rest of the time is yours.